Hi, we're Team The Dork Side. I'm Megan Butler.
I'm Emma Devira.
I'm Courtney Bredden.
I'm Cindy Nguyen.
And I'm Ayame Kubota.
We're from the Mount Gravatt campus in the 10 to 12 tutorial.
Today we're going to talk about everyday materials changing in a variety of ways.
In regards to the Australian curriculum, this topic can be found within the Year 1 science curriculum. Through the content descriptor, everyday materials can be physically changed in a variety of ways.
Within this content descriptor, the elaborations identify the important ideas. These are
how Aboriginal and Torres Strait Islander peoples apply physical changes to natural materials to render them as useful for particular purposes.
Predicting and comparing how shapes of objects made from different materials can be physically changed through actions such as bending, stretching, or twisting.
Finally, we need to teach the children about how materials such as water, chocolate, or Play-Doh change when warmed or cooled.
Through the content descriptor and elaborations, we can identify that the key concepts from these is changing physical states of matter.
Throughout this chemical sciences video, we will identify and explain the current dominant scientific understanding, identify the learning outcomes, and discuss how we may bring this into our classrooms.
Finally, we will look at a range of ICT resources that help Year 1 students understand the concept in an engaging way.
We will analyse and critique each of these and justify why we believe that one of these is the best of the best. To understand the current dominant scientific understanding for the concept of physically changing a variety of materials in different ways, firstly, we need to make sure that students understand what matter is and the different states of matter. Matter is what makes up the universe. It is anything that has mass and can take up space. The three states of matter are the forms in which matter can exist in. These are solids, liquids, and gases. According to theoretical physicist Deepak Dar, solids have a fixed shape and a fixed volume, but liquids have a fixed volume but no fixed shape, while gases have neither a fixed shape nor a fixed volume. A solid's particles are so tightly packed together that the bonds between them are strong enough to not allow for particles to move freely. Similar to solids, a liquid is a state in which is subject to intermolecular attraction, the attraction between molecules. However, the bonds between a liquid's particles allow for more free-flowing space, unlike the solid state, where its particles are locked in place. Gases, however, have very weak bonds or no bonds at all between its particles. This means that gases are able to flow freely and very quickly.
When changing the states of matter from one to another, energy needs to be applied or taken away to cause a physical or chemical change. By adding energy, it causes the molecules to convert from one state to another. For example, if heat is the energy and is applied to liquid water, it will convert it into steam, which is a gas. We can see this through when we boil water in a kettle or on the stove. The liquid starts to form into a gas that we can see coming from the top. This is called evaporation. Taking away energy will also cause a physical change. For example, when heat is removed from liquid water, it becomes ice, which is a solid. This is similar to when we buy Zupa Dupas at the shops, a type of ice block. They start as a liquid, but when we put them in the freezer, they become a solid because they're placed into a colder temperature. These physical changes are also reversible. We can see this through the example of chocolate. If we buy a block of chocolate, it starts as a solid. However, we can heat this to make it into a liquid to use for cooking. And then simply by cooling it again in the fridge, it becomes a solid once again. We can also change everyday materials by either bending or stretching them. Bending is when we apply force by pushing or pulling parts of an object towards each other to make it curved. Stretching is when we make an object wider or longer by two opposing forces pulling it away from each other. We can use Play-Doh for an example of it having the ability to bend and stretch, then being able to return back to its original shape. However, there is a huge amount of different materials that we can bend and stretch. Some of these will return to their original shape and others won't.
There are many learning outcomes that are identified when students are being taught about the physical changes in everyday materials. The students will be able to identify the different states of matter, solids, liquids, and gases. Students will also make predictions about how shapes of objects change in different ways and compare these physical changes to their original state. Finally, through observation, they will be able to identify and explain how we can change solids, liquids, gases, and other everyday materials into different states by bending, stretching, heating, and cooling.
The criteria that we used to evaluate our ICT resources were age appropriateness, entertainment and engagement, alignment with the CDSU, and curriculum relevance. We will speak briefly about this, however, please pause the video when the table is displayed for each resource for further analysis. The first resource that we have identified as one of the best is a game called What is the Matter? This game identifies the different states of matter but does not explain what they are or how states of matter can change. So, this game was given a score of 9.5 out of 20 due to it not aligning completely with the curriculum and the CDSU. However, this resource is very engaging and entertaining as students will be able to have fun and compete against each other. The second resource is a game which focuses on changing the states of water. This one was scored 10.5 out of 20, due to it focusing on changing everyday materials into different states of matter. This aligns with the CDSU and curriculum. This game is not particularly engaging as the information is not in depth. It simply shows water freezing and melting and also relies on the students reading, which means it is not very age appropriate as there is no voiceover.
The third resource is a YouTube video explaining the states of matter, which was rated quite highly throughout the criteria and gave a score of 15 out of 20. The video explains the states of matter and how we can change them into different states through heating and cooling. It aligned well with the CDSU and curriculum category. This video is engaging through the use of pictures, however some of the terminology used are way too advanced for Year 1 students as they would struggle to understand. The fourth resource is a game that focuses on the states of matter, which was scored 11.5 out of 20. The video explains the states of matter and identifies them in depth. Therefore, this resource does not align well within the CDSU and the curriculum as well as the other resources. However, it is fairly age appropriate as a Year 1 student would most likely have no problem working through the game. The game, however, does not take that long to complete, so therefore would not be very engaging for the students.
Finally, our last resource, which we consider our best of the best, is a video about the states of matter and how we can change water into different states. We gave this a 15.5 out of 20, as it addresses both parts of the CDSU and curriculum, and therefore we scored these two criteria quite high. However, the video is very engaging as it uses language students would understand and uses an example of a football player to explain matter. Therefore, we consider this our best of the best as this would be suited to implement into our future classrooms. These resources could be further improved to perfectly align with the curriculum by referencing other everyday materials physically changing shape or bending, stretching, or twisting.
The process of learning can be disengaging and challenging without the use of an appropriate teaching and learning model in the classroom. The 5E pedagogy is a constructivist approach which allows students to be actively engaged in a range of learning activities. Learners are encouraged to build upon their prior knowledge, ask questions, be involved in hands-on learning activities and conduct investigations to ensure all students understand the accurate CDSU. This model has 5 phases: engage, explore, explain, elaborate, and evaluate. We believe that the best of the best ICT resource, Solids, Liquids and Gases video, should be incorporated into the first phase of engage within the 5E pedagogy. The engage phase aims to stimulate the student's prior knowledge and helps to develop an interest in a specific topic. This video allows engagement from the learners as they can understand and establish connections of their prior knowledge and the new ideas with the use of real-life examples to explain the concept of physically changing states of matter. The constant visuals of the animation and bright colours leave no time for students to be distracted, therefore providing opportunities for students to develop an interest in the topic.
One downfall is that instead of using degrees Celsius, this video uses temperature in Fahrenheit. As a result, it would be explained to the students that we measure temperature using degrees Celsius. As a class, we could go on to discuss the freezing and melting points are in degrees Celsius. This would be a good way to get around our only major problem with our best ICT resource. This effective resource would be enhanced through using additional resources, such as looking at other everyday materials and how we can physically change them, alongside our best of the best to help support an introduction of the unit. Subsequently, throughout the 5E phases, hands-on activities will be done to further extend students' learning. Overall, our choice of the best ICT resource is suitable to use in the Engage phase before moving on to other phases in this model.